Hey guys, good morning or good afternoon, depending on which class I'm talking to. Happy Friday. I hope you're having a good day. First thing I want to say is Happy Earth Day. I know Earth Day was yesterday, but I didn't see you yesterday. So I want you to think about something good that you can do for the planet either today or this coming week. And then here's what else I want you to do today. So you guys are going to be working on an abnormal karyotype activity. And then I'm going to show you that there is going to be an optional extra credit opportunity that you're going to have a week to work on. And keep in mind, I posted the other day the basic genetics vocab that is due Monday morning at 9 a.m. So that's something else that you can be working on too, depending on how you work through the other two activities or other one activity. The one is going to be optional. Okay, so when you head over to the classwork tab, you will see the abnormal karyotype activity that posted. This is what you have to do today. So this is a major assessment. Complete the abnormal karyotype activity linked below. Be sure to read the directions on slide 1, 5, and 7. So if you go ahead and open up the slides, slide 1 has a picture of a karyotype and then some instructions on using this picture. Also what we have learned in previous lessons to answer the questions on slide 2, slide 3, and slide 4. So you're just filling in the blanks there. Slide 5 gives us some new instructions. You are given some information about some chromosomal non-disjunction disorders. So you're going to read through those. Tells you to use this information to answer the questions on the next slide. So you're going to read through the different disorders or syndromes. Slide 6, you're going to read about 5 different patients, and you are going to, based off of what you read on the previous slide, match up the syndrome to the patient. Okay, slide 7, we have some more instructions. Tells you to click on this karyotype activity link, and I'm actually going to walk you through the first example on this activity. So you're going to click on that link. You are going to read through this information and then click Patient Histories. You can read a little information about each of the 3 patients you're going to be examining, their karyotypes today. And then you're going to start by clicking Patient A. And what this is asking you to do is complete this patient's karyotype. So you have a partially completed karyotype down here, and you have a chromosome here. You are going to find its homologous match. So you will notice that only a few options are highlighted in blue. They're the ones that you're picking from. So remember, we're looking for similar length, banding pattern, centromere position to match up homologous chromosomes. So I'm going to go ahead and work through this. You're just going to click where you think the match belongs. If you're correct, it will tell you, and it will give you the next chromosome to pair. If you're incorrect, it will let you know that you're incorrect. So you're going to keep going, matching up the homologous pairs. Then it tells us now we have paired up all the chromosomes. Where does this extra chromosome belong on the karyotype? So all of the disorders that we're looking at today are a result of non-disjunction. We know that the chromosomes did not separate correctly during some part of meiosis, making there be too many chromosomes or not enough chromosomes. So we're going to find the match here. If you got it right, it'll tell you congratulations. And then you're going to read about how you interpret a karyotype and notation that scientists use to record the information on the karyotype. And then it asks you a question, which on your directions on the slide, it tells you to put your answer to this question in the chart. And if you keep scrolling down, it's going to ask you another question about your final diagnosis, and it will give you some examples of disorders that we can be picking from. If you scroll all the way to the bottom, you will see the completed karyotype that you made. Warning, do not hit the back button. You'll have to redo matching up all those homologous pairs again. So make sure that you scroll all the way down to the bottom if you want to look at the karyotype and see where you had an extra or not enough chromosomes. Don't hit the back button. If you do, you'll just have to redo the matching up to move on. So I'm going to go ahead and click over onto our slides here. The instructions tell you this, but I'm looking at patient A, and I'm going to fill in the total number of chromosomes, the sex chromosomes on this karyotype, and then what the final diagnosis is. So if I click back over and I look at the chromosomes, we know that a normal karyotype has 46 chromosomes, right? I have 22 pairs plus the 2 sex chromosomes, so that's 44 autosomes plus the 2 sex chromosomes for a total of 46 chromosomes. However, in this particular karyotype, we added an extra chromosome to chromosome 21. So that means the total number of chromosomes is 46 plus that 1 extra chromosome. You also could literally just count up all the chromosomes, and there are 47 there. So that is what you would be filling in for number of chromosomes. Now I need to find the sex chromosomes. Our options, remember, are X or Y, and some combination of those depending on the patient we're looking at. So if I look over here, I have 2 chromosomes that are the same. So this must be XX. So that is what I'm going to fill in here. Sex chromosomes are XX. The abnormality, I already have filled in for you here as an example. But what that means is we know that a normal karyotype has 46 chromosomes, but this karyotype has 1 extra. I want to know where that 1 extra is. So this plus 21 is telling me that there is 1 extra chromosome, number 21. Go ahead and look at that again, and we can see 1, 2, 3, right? There's an extra chromosome there. I also want to point out with the sex chromosomes, I know that you might be thinking, well, this chromosome is like a little bit shorter than this chromosome. When you see the X and Y chromosomes compared, the Y chromosome is much, much, much smaller than the X chromosome. It is very noticeable. What probably happened here is these are actual chromosomes that had a picture taken of them. I have a feeling this chromosome is kind of just bent a little bit in the plane that we can't see. So it's like bent behind that chromosome. Again, when you're looking, when XY is the answer, the Y is much, much smaller. It's very easy to tell the 2 sex chromosomes apart. Okay, so now that we have our chart filled in, we have 47 chromosomes, XX. This patient is a female, and that there's an extra chromosome, number 21. We need to figure out the diagnosis. So if I scroll up a little bit here to this diagnosis chart and I read through, we'll see that an extra chromosome number 21 is called, it can also be called trisomy 21, meaning there's 3 chromosome 21s. And that extra chromosome number 21 is actually what results in Down syndrome. So for my diagnosis, that's what I would put here. I would also accept the trisomy 21 there. So you're going to go ahead and work through the rest of the patients. So once you're done with patient A, you can move on to patient B, and you're going to do exactly the same thing. When you are all done all the slides, you can click turn it in on that activity. That is what is due. It'll be due actually on Monday morning by 9 a.m. like all of our assignments in class. There is also an optional extra credit opportunity that we'll be posting towards the end of the period. And it's looking at an abnormal karyotype, and you can read through that. You have a week to get that done. It'll be graded out of 10 points. And again, it's optional extra credit. And just to keep in mind, if you do finish early or if you have not completed yet for homework, the basics genetics vocab homework is due on Monday by 9 a.m. Let me know if you have any questions, and I hope you have a great weekend.